Good morning students. Exercise 3.3 fourth question. Prove that cot of 180 degree plus theta sin of 90 degree minus theta into cos of minus theta the whole divided by sin of 270 degree plus theta tan of minus theta into cosecant of 360 degree plus theta that is equal to cos square theta into cot theta. We have to prove. Okay, I'll take the first term, cot of 180 degree plus theta. So I have said already. So first you have to determine the sign for this trigonometry ratio. So look at your angle first, 180 degree plus theta. So along with 180 degree, some acute angle is added with that. So therefore definitely it lies in the third quadrant. So using ASTC rule, in the third quadrant, tan theta and cot theta are positive. Here the trigonometry ratio also cot, so it is positive. Okay, so next you have to see which is it. Is it a odd multiple of 90 degree or even multiple of 90 degree? So here it is 180 is given. So 180 degree is a even multiple of 90 degree. If it is even multiple of 90 degree, you need not change the trigonometry ratio. So that's why I have written it is cot theta. And come sin of 90 degree minus theta. So it is a complementary ratio. Sin of 90 degree minus theta is equal to cos theta. And you know very well the formula, cos of minus theta is equal to cos theta. So I have completed the numerator. Come to the denominator, the first term, sin of 270 degree plus theta. First you have to decide about the sign. So 270 degree plus theta. So it comes in the fourth quadrant. So using ASTC rule, in the fourth quadrant, cos theta and secant theta are positive. But here what it is sine. So you have to put the minus sign. Okay, and you have to check whether it is an odd multiple of 90 degree or even multiple of 90 degree. Here it is 270 degree. So it is an odd multiple of 90 degree. So therefore the trigonometry ratio has to be changed as sin is here. So it has to be changed as cos theta. And you know very well tan of minus theta is equal to minus tan theta. And come to the last one, cosecant of 360 degree plus theta. So 360 degree plus theta. So 360 degree is one full complete rotation. Okay, 360 degree, it's one full complete rotation. So after that some angle is added, some acute angle is added. So therefore it lies in the first quadrant. Okay, so 360 degree plus theta lies in the first quadrant. So in the first quadrant all are positive. So here I didn't write any symbol. So it means it is positive. And go for 360 degree. So one full complete rotation is over. So the remaining angle you can write. So it is cosecant theta. Okay, so see now I have substituted. In the place of cot 180 degree plus theta is cot theta. Likewise, I have written all the 6 terms. You see that now minus into minus, plus in the denominator, and 1 cos theta getting cancelled. So the remaining is what here? Cot theta into cos theta. Cot theta you know very well. It is cos theta by sin theta into cos theta. So this cos theta and here cos theta getting cancelled. Here you are having tan theta. Tan theta is nothing but sin theta by cos theta. What is cosecant theta? That is 1 by sin theta. Okay. See now cos theta into cos theta is cos square theta, and see that here in the numerator the denominator is sin theta. In the denominator also the denominator is sin theta. Otherwise, we will see now this sin theta getting cancelled. So cos theta into cos theta is cos square theta. In the denominator you are having sin theta. Here this cos theta, where it is? Denominator of the denominator. So it will come sin theta by cos theta. In this sin theta, it's a numerator denominator. Okay, you see that now. this sin theta and the sin theta getting cancelled. Cos theta into cos theta is cos square theta divided by sin theta by cos theta. What is sin theta by cos theta? That is tan theta. So it is in the form of 1 by tan theta. It's a reciprocal of tan theta. So that is nothing but cot theta. So we have proved cos square theta into cos theta. Okay, so we'll move to the next problem. So it's a problem number 5. Okay, find all the angles between 0 degree and 360 degree which satisfy the equation sin square theta is equal to 3 by 4. You consider the equation sin square theta is equal to 3 by 4. Upon sin theta you have to take the square root. So we have to write plus or minus square root of 3 by 4. So it is plus or minus. So root 3 by 2. So first take the positive value. Sin theta is equal to root 3 by 2. Okay, sine of which angle having the value root 3 by 2? It is 60 degree. So now 60 degree lies in the first quadrant. So we want 0 degree to 360 degree. What are the angles are there? Satisfy this equation we have to find out. Okay, I'll take 120 degree. So sine 120 degree I have taken. The sine 120 degree can be written as sine of 180 degree minus 60 degree. Isn't it? Sine of 180 degree minus 60 degree. Okay, so check the quadrant. You have to determine the sign for this. So 120 degree or 180 degree minus 60 degree. 180 degree is second quadrant. So some angle is subtracted. So it is less than 180. So therefore it lies in the second quadrant. In the second quadrant your sign is positive. And you see that it is a even multiple of 90 degree. It's a even multiple of 90 degree. So you need not change the trigonometry ratio. So therefore it will be sin 60 degree. The value is root 3 by 2. So therefore sin 60 degree and sin 120 degree having the value root 3 by 2. And go for the next value. Sin theta is equal to minus root 3 by 2. Okay. So see that here I am going to consider sin 240 degree. So sin 240 degree, how you can write? It is 270 degree. You can use 270 degree. Okay, minus 30 degree you can go for it. 270 degree minus 30 degree. I have written it is 180 degree plus 60 degree. Okay, so 240 in which quadrant it lies? It lies in the third quadrant. In the third quadrant, tan and cot is positive. Here you are having sine. So therefore, I have written the minus sign. Okay, and 180 degree is a even multiple of 90 degree. So therefore, you need not change anything. It is sine 60 degree. So sine 60 degree is what? Root 3 by 2. So you are getting the value minus root 3 by 2 for the angle 240 degree. And one more I can consider. What it is? Sin 300. Sin 300 can be written as sin 360 degree minus 60 degree. 300 lies in which quadrant? Fourth quadrant. In the fourth quadrant, which are positive? ASTC rule. Cos and secant are positive. So here what is given? Sin is given. So it is minus. And 360 degree is a even multiple of 90 degree. So I have written as sin 60 degree. So the value is minus root 3 by 2. So therefore, sin theta is equal to minus 3 by 2 means your theta is equal to 240 degree and 300 degree. So these four angles lies between which one? 0 to 360 degree. Okay, so coming to the sixth problem, sin squared pi by 18 plus sin squared pi by 9 plus sin squared 7 pi by 18 plus sin squared 4 pi by 9 is equal to 2. So we have to prove that it is equal to 2. Okay, consider the terms, the four terms left hand side, and you just write the first term sin pi by 18, that can be written as cos of 90 degree minus theta, because cos of 90 degree minus theta is equal to sin theta. So I consider pi by 18 is a, what is a theta? So sin pi by 18 can be written as cos of 90 degree. Instead of degree I have written in radian. So 90 degree can be written as pi by 2 radian. So pi by 2 minus pi by 18. Here you are having sin squared. So that's why I have written cos squared. In the same way, take the second term. It can be written as Sin pi by 9 can be written as cos of 90 minus pi by 9. So here you are having, it is square, so this also it is square. The third term and the fourth term I have written as it is. Okay, so see here you are going to take the LCM. What is the LCM? 18 is the LCM. So here you are having 2, so it has to be multiplied with 9. So 9 pi minus pi divided by 18. The same way if you take LCM, here also 18 will be the LCM. So 9 pi minus 2 pi. Okay, so third term, fourth term, I didn't change anything. So first term is cos squared. 9 pi minus pi is 8 pi by 18. Okay, plus cos squared. 9 pi minus 2 pi is 7 pi by 18. Okay, is it clear? So when you divide it by 2, what is this? 4 pi by 9. For cos squared 4 pi by 9 plus cos squared 7 pi by 18 plus sin squared 7 pi by 18 plus sin squared 4 pi by 9. You consider the first term and the fourth term. It is in the form of angle is same 4 pi by 9, but it is cos squared theta plus sin squared theta. So it can be written as 1. So you know the identity. In the same way, consider the second term and the third term. So if you group, the angle is same. So this also it comes under the formula cos square theta plus sin square theta. So 1 plus 1 is equal to 2. Okay. So exercise 3.3 is over. Next one, we are moving to the important session in the trigonometry. So trigonometric identities. Okay. So first identity is cos of alpha plus beta. So it should not be written as cos alpha plus cos beta. Okay. So cos of alpha plus beta is equal to cos alpha cos beta minus sin alpha sin beta. So to prove this identity, I have considered the unit circle. What circle? Unit circle. Unit circle means what? Whose radius is 1. So what is the radius here? OR and OS. So it is 1. Okay, and so this OP also the radius. So we'll consider the point P, okay, in such a way that whose coordinate is 1, 0. So OP, OR and OS, they are nothing but the radius is 1. Okay, so this point is 1, 0. So I'm going to take the 3 points. One is Q, R, S in such a way that angle POQ is equal to alpha. See now, angle POQ. You see that first we'll consider the unit circle. So unit circle means the radius is 1. So I'll consider the point P, okay, in such a way that whose coordinate is 1, 0. So P is on the x-axis. And I'm going to consider 3 more points. One is Q, another one is R, and another one is S in such a way that POQ, this angle is alpha, POQ angle is alpha, and what is it? QOR, what is it? QOR is beta. In the same way, POS is minus beta. So we consider the point Q whose angle is POQ is equal to alpha, and R, so we'll consider R, it is QOR is equal to beta. In the same way, POS is equal to minus beta. You see the direction. POQ is alpha. It is anti-clockwise. It is positive. In the same way, QOR is nothing but beta. That is also in the anti-clockwise direction. So it is positive. So here QOR, which is equal to POS. But the POS I have taken in the clockwise, so it is written as minus beta. Okay, so in such a way that we have taken the points Q or S on the, what is it? On the circumference of the circle. Okay, so you know very well, any point on the circumference of the circle is, you can write cos theta, sin theta. What? Any point on the unit circle is cos theta, sin theta. Now you see that what is the coordinate of P? So it is nothing but cos 0, that is 1, and sin 0 is 0. So that is 1 comma 0. Okay, and next one, Q point. You see the angle. What is the angle is here? POQ. Okay, POQ. What is the angle? It is alpha. So it can be written as cos alpha comma sin alpha. Okay, and you see now R point. So you see that R. So from the x-axis, what is the angle is made? It is alpha plus beta. So we have taken QOR as beta. So from POR, what is it? It is alpha plus beta. So therefore the R point is cos of alpha plus beta and sin of alpha plus beta. Okay, and come to here, yes. Okay, yes, the coordinators cos theta comma sin theta. Here the angle is what? Minus beta. So therefore it is cos of minus beta and sin of minus beta. So these 3 points are very, very important. The first step, we consider the unit circle. So whose radius is 1, and we'll consider the point P having the coordinate 1 comma 0, and you see Q, R, S, the 3 points on the unit circle. How you have to take? POQ is equal to alpha and POR is alpha plus beta and POS is minus beta. So therefore the coordinate of P is 1 comma 0 and the coordinate of Q is cos alpha comma sin alpha and the coordinate of R is cos of alpha plus beta and sin of alpha plus beta and the coordinate of S is cos of minus beta and sin of minus beta. Okay, so now you are going to consider the two triangles. What are the triangles are you going to consider? You see that one is POR, another one is, what is it? QOS or SOQ. You see the way POR and SOQ, they are congruents. They are congruent. Why it's so? You see that OR, it's a radius. Here also OS is the radius. Okay, both are same. And see the angle POR. What is it? Alpha plus beta. In the same way, QOS. So QOS, anti-clockwise la. You see now this is alpha. Here anti-clockwise if you measure it is beta. So therefore QOS is nothing but what is it? Alpha plus beta. Otherwise you can say SOQ. It is what it is, anti-clockwise measure panningna, it is beta plus alpha. So the two this side are equal, the angles are equal. Okay, and see OP is the common side. Okay, so therefore which triangles are congruent? So POR and SOQ, these two triangles are concurrent. So therefore next one, PR is equal to QS. Since the two triangles are congruent, so therefore PR is equal to SQ. That is a very, very important result here. Okay, so PR is equal to SQ. So you consider squaring on both the sides. So PR squared is equal to SQ square. Next I am going to find what is PR squared. So P is, what is it? P point is, what is it? It is 1 comma 0. And next one you need R. R is what? Cos of alpha plus beta and sin of alpha plus beta. So the 2 points are, you know very well. So how to find PR? It's a distance formula. So it is a square root of, what is the R point? You see now R is cos alpha plus beta comma sin alpha plus beta. P is what? 1 comma 0. Use the formula square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So in the place of x2 what I have written? Cos alpha plus beta minus 1 the whole square plus y2 sin alpha plus beta minus 0 the whole square. You see that I have written here. cos alpha plus beta minus 1 the whole square plus sin alpha plus beta minus 0 the whole square. Why I have squared here? It is given as PR squared. So PR distance I have written using the square root, the whole square. And this square and the square root getting cancelled, you are having this term. Isn't it? Okay, so it is in the form of a minus b the whole square. What is it? A squared plus b squared plus 1 minus 2ab, 2 into 1 into cos of alpha plus beta, plus this is sin of alpha plus beta minus 0 is sin alpha plus beta the whole square. That can be written as sin squared alpha plus beta. You consider the first term and the last term. The angle are equal. It is in the form of cos squared theta plus sin squared theta. So combining the first and the fourth term, it is 1. And here also second term also you are having 1. Next, minus 2 cos of alpha plus beta. What is 1 plus 1? It is 2. 2 minus 2 cos of alpha plus beta. You should not subtract 2 minus 2, 0. You should not do that. This 2 was multiplied with cos of alpha plus beta. So you have to write 1 plus 1 is 2 minus 2 cos alpha plus beta. I have found the PR square. Next one which is needed, SQ squared is needed. So we have to find out what is SQ. So look at this. S this point and Q is this point. Okay, again you have to use the distance formula. So square root of x2 minus x1. So cos alpha minus cos of minus beta the whole square plus y2 minus y1 sin alpha minus sin of minus beta the whole square. So cos alpha minus cos of minus beta the whole square plus sin alpha minus sin of minus beta the whole square. So SQ square. So I have written the whole square. So this square and the square root getting cancelled. Here cos alpha minus, you see that, you know very well, cos of minus theta is what? Cos theta. So here I have written cos beta. Okay, in the same way here come to here, sin of minus theta is what? Minus sin theta. Already in the formula you are having minus. When you apply this you will get one more minus. So minus into minus plus sin beta the whole square. Okay, so it is in the form of a minus b the whole square. So therefore a squared plus b squared minus 2ab, and this is in the form of a plus b the whole square. So a squared sin squared alpha plus b squared, that is sin squared beta, plus 2ab, 2 into sin alpha sin beta. Okay, see the first term and the fourth term. Cos squared alpha plus sin squared alpha is 1. In the same way, second term and the fifth term, cos squared beta plus sin squared beta is 1. So the remaining these two terms. So from these two terms, I have taken minus 2 out. If I take minus 2 out, here it is remaining as cos alpha, cos beta. From this term, if you take minus out, here you are having minus sin alpha, sin beta. Okay, so what is 1 plus 1? It is 2. 2 minus 2 into cos alpha cos beta minus sin alpha sin beta. You have to mark this as 3. So in the first result, what do you know? PR squared is equal to SQ squared. So we have to equate it. So from 1, 2 and 3. So you know that PR squared is equal to SQ squared. I have substituted what is PR square and what is SQ square. First you have to cancel these two. So the remaining is minus 2 cos of alpha plus beta is equal to minus 2 cos alpha cos beta minus sin alpha sin beta. This minus 2 getting cancelled. You are having the first identity, cos of alpha plus beta is equal to cos alpha cos beta minus sin alpha sin beta. Okay, so we'll go to the second identity, cos of alpha minus beta is equal to cos alpha cos beta plus sin alpha sin beta. So you know very well. So we have proved this identity very clearly. So take that identity. Cos of alpha plus beta is what? Cos alpha cos beta minus sin alpha sin beta. Here what you have to prove? Cos of alpha minus beta. How this can be written as alpha plus minus beta. So when you compare these two, in the place of alpha you are having alpha, but in the place of beta you have to substitute minus beta. Take the previous result. In the place of beta you have to substitute minus beta. Appa cos alpha, cos of minus beta, minus sin alpha, sin of minus beta. What is cos of minus theta? Cos theta. What is sin of minus theta? Minus sin theta. So here it will become plus. So therefore cos of alpha minus beta is what? Cos alpha, cos beta plus sin alpha, sin beta. So in the same way, we'll go to the third identity. What is it? It is sin of alpha plus beta is equal to, you see the term, sin alpha cos beta plus cos alpha sin beta. So the terms are changed, okay? Sin and cos is involved. Okay, so you know the identity. Cos of alpha minus beta is what? Cos alpha cos beta plus sin alpha sin beta. You take that identity. So you are going to take sin of alpha plus beta only we have to prove. So sin theta can be written as cos of 90 minus theta. Appa cos of 90 ku bala you have written as pi by 2 minus, what is your theta? Alpha plus beta. So this has to be rearranged. Okay, pi by 2 minus alpha. Here you are having minus beta. Okay, so pi by 2, if you apply the minus sign, what has to come? Pi by 2 minus alpha minus beta. So pi by 2 minus alpha you have to group as a single term. The remaining is what? Minus beta. How it looks like? Cos of alpha minus beta. So in the place of alpha, what you are having? Pi by 2 minus alpha. In the place of beta, you are having beta. So in this formula, in the place of alpha, you have to substitute what? Pi by 2 minus alpha. So cos of pi by 2 minus alpha. Beta la endha change illa. So cos beta is written as it is. Plus here sin of alpha. Alpha how it is changed? Pi by 2 minus alpha into sin beta. You know very well. Cos of 90 minus theta, sin theta. So cos of pi by 2 minus alpha is sin alpha, cos beta plus sin of 90 minus alpha is cos alpha into sin beta. So we have obtained the third identity. What is it? Sin alpha plus beta is equal to sin alpha cos beta plus cos alpha sin beta. So next identity, fourth one. What is it? Sin of alpha minus beta. What is sin of alpha minus beta? Sin alpha cos beta minus cos alpha sin beta. Okay, take this identity. We have proved just now. Take that. In the place of, here we what we have to write? Sin of alpha minus beta. Arrange according to this term. So it can be written as alpha plus minus beta. So in the place of alpha, you have to write alpha, but in the place of beta you have to write minus beta. So in this term, in the place of alpha there is no change, you have to write alpha, but in the place of beta what you have to write? Minus beta. So here cos alpha into sin of minus beta. You know very well, cos of minus theta is cos theta, but sin of minus theta is minus sin theta. So when the minus come here, it will become minus cos alpha sin beta. So sin of alpha minus beta is equal to sin alpha cos beta minus cos alpha sin beta. So we'll go to the next identity. Identity 5. Tan of alpha plus beta is equal to tan alpha plus tan beta divided by 1 minus tan alpha tan beta. So see the proof. Tan of alpha plus beta, how it will be written? So tan theta can be written as sin theta by cos theta. So sin of alpha plus beta divided by cos of alpha plus beta. You know the formula. Sin of alpha plus beta is what? Sin alpha cos beta plus cos alpha sin beta. Cos of alpha plus beta can be written as cos alpha cos beta minus sin alpha sin beta. So the numerator and the denominator has to be divided by cos alpha cos beta. Okay, this is the common denominator. So what you have to do? So you have to divide the first term by this. So sin alpha by cos alpha is tan alpha. Cos beta getting cancelled. Go to the second term. Cos alpha cos alpha getting cancelled. Sin beta by cos beta is tan beta. So come to the denominator. Cos alpha cos beta is cancelled with cos alpha cos beta, so it is 1. Minus, here sin alpha by cos alpha is tan alpha, sin beta by cos beta is tan beta. So tan of alpha plus beta is equal to tan alpha plus tan beta divided by 1 minus tan alpha into tan beta. Okay, in the same way, what is identity number 6? Tan of alpha minus beta. How it will be written? Tan alpha plus tan alpha minus tan beta divided by 1 plus tan alpha tan beta. So here we have learned 6 identities. These are very important. Okay, so I have written all the identities together. Okay, you look at your sin alpha plus beta and sin alpha minus beta. So sin cos is involving. So if you are having plus, here also plus. Here if you have minus, here also minus. Sign is not changed. If here alpha plus beta, here in between you have to write plus. And cos alpha plus beta, cos alpha minus beta, you see that first term cos and the second term is sin. Here if you have plus means here you have to write minus. Here if you have alpha minus beta means in the term you have to write plus. So tan alpha plus beta, tan alpha plus tan beta divided by 1 minus tan alpha tan beta. Tan of alpha minus beta is equal to tan alpha minus tan beta divided by 1 plus tan alpha tan beta. So the 6 identities are very important. If you know these 6 identities, then only we can do the next exercise in trigonometry. Thank you, students.